Good morning. My name is Abdel Nasser Eldek. I am a professor in the Department of Electrical and Computer Engineering at Jackson State University. Today I will talk about our experience here at Jackson State with the Analog Discovery Board and the analog part kits. The Analog Discovery Board turns a PC into a powerful electrical engineering workstation. It lets a student measure, visualize, analyze, record, and control mixed signal circuits for all kinds. It is so small that it can fit in your pocket, but so powerful that it can replace a stack of lab equipment. It is driven by a free software called Waveforms, and this Analog Discovery Board lets the student build and test analog and digital circuits anywhere in any environment. The only two limitations, in my opinion, in Analog Discovery Board are: number one, the maximum DC voltage that Analog Discovery Board provides is only positive and negative 5 volt, and number two, it doesn't measure current. However, we can overcome the first limitation by carefully selecting the components we use in the experiment, or by using batteries or voltage adapter. And also we can overcome the second limitation by simply using a portable multimeter. In addition to the Analog Discovery Board, we use Analog Parts Kit, which contains a lot of selection of components for creating a wide variety of useful circuits and devices. It includes transistors, resistors, capacitors, diodes, sensors, and a variety of useful ICs, including op-amps, converters, and regulators. We started using Analog Discovery Board and Analog Parts Kit when we participated in an SF project called Experimental Centric Based Engineering Curriculum for HBCUs. We use them in a number of classes like electric circuits, embedded systems, and senior design. However, the major work was done in electric circuits. In electric circuits lab, we redeveloped all the experiments and designed a new lab manual depending mainly on Analog Discovery Board and Analog Kit. Each lab now consists of three main parts. Number one, calculation, where the student solve most of the circuits theoretically and calculate certain voltages and currents. Then number two, the student verifies his calculation results using PSpice. Then number three, the student builds the circuit and do all measurements using the Analog Discovery Board and Analog Parts Kit, in addition to a portable digital multimeter. This new design for the lab has a lot of benefits for the students and for the university too. It lets the student practice on using the theorems to solve circuits, and then it lets them also practice on using simulation software like PSpice. And finally, what's the most important here, is that they build a real circuit and do all the measurements. They do all that without the need to come to the lab. They can do it anywhere at their convenience, and at the same time they still can come to the lab to use and practice on the original equipment if they want. I asked many students in 3 different semesters now about their opinion, and it was very clear that they are very happy and very satisfied doing the lab this way. In addition, since I started using Analog Discovery Board, the number of students was doubled in the lab. Last semester I had 39 students in the lab. Usually we allow only 20 students because of the limited number of workstations. But now we can register more. Also, we can register them even if there is a conflict of time with other classes, and this allows more students to register for this lab. I believe that this experiment was very successful, and that's why we are working now in generalizing this in other labs like digital logic and electronics, and we try to find out how can we use this board or similar boards in other labs also. I hope you enjoyed my talk, and you are welcome to contact me if you have any questions. Thank you very much.